Good morning, CP Calculus class. This is Miss G. It is Monday, March 30th. I hope you all had a nice weekend. So today we're starting a new section, section 5.3. It's called Exponential and Logarithmic Integrals. And today's lesson is going to focus on exponential integrals. This should be a fun little lesson for you. It's not too hard, and I think it'll be fun. Okay. So let's see what we've got. We've got, if you remember from chapter 4, section 4.3, when we took the derivative of e to the x, we got e to the x. Y prime was e to the x. So if the derivative of e to the x is equal to e to the x, then if we integrate e to the x, our derivative, to get back to the original function, guess what the original function is going to be? E to the x. So the integral of e to the x dx is e to the x plus c. Why? Because the derivative of e to the x plus c is e to the x. And then the derivative of c is 0. So there are two rules really here. One is that the integral of e to the x dx is just e to the x plus c. But let's suppose the problem is more than just e to the x. It's e to the some function of x. Then we can do a u/du substitution, which you'll see in a minute, and we'll reduce our problem down to the integral of e to the u. So if we integrate e to the u du, guess what we get? E to the u plus c. And then at the end of that problem, we would substitute the x's back in, just like we did in all the other problems for u/du substitutions. So the basic one is the integral of e to the x dx, which gives us e to the x plus c. But if we end up doing a u/du substitution to simplify our original problem down to e to the u, and we integrate that, then we will get e to the u plus c. All right, let's try a few of these. So, our first example is the integral of 2e to the x dx. Now, that's like the original rule we have here, but we have a 2 in the problem. Now, we can't get rid of that 2. It didn't show up in a du. We don't need a u/du substitution in this problem because this is just an x, this function right here, this exponent. And 2 we can't get rid of. So 2 is just a coefficient. We can pull the 2 in front of the integral and just integrate e to the x dx. And we know that the integral of e to the x dx is just e to the x plus our c, and then we bring the 2 down. And there you have it. The integral of 2 e to the x dx is 2 e to the x plus c. Hope that's not too bad. Let's try another couple of problems. Let's look at this one. This one is not quite as simple as the one we just did because it's the integral of 2e to the 2x. Now we have a function within a function. The 2x is inside the exponential function. It's acting as the exponent. So now we're going to do a u/du substitution, and when we go to look for our inside function, it ends up being the exponent on the e. So our u is 2x. The derivative of that, our du, the derivative of 2x, is 2 dx. Well, that's exactly the rest of the problem. We have the 2 and the dx here, and that came up in our du. So our substitution is simply the integral of e to our exponent u, which is 2x, but we're representing it by u, and then the du covers the rest of the problem, the 2 dx. So we don't have to move this 2 in front. We don't have to multiply by a 1/2. This is the perfect match problem. The du is the rest of the problem, 2 dx. So we're just integrating e to the u du, which we saw in our rule before. The integral of e to the u du is e to the u plus c. So the integral is e to the u plus c. And the last step is we take out the u's, we put the x's back in. So we get e to the 2x. Oh, I forgot to do that. Wait, we have to put in, this is going to equal e to the 2x plus c. And now we're done. All right, let's see what the next one is. The next one is the integral of e to the x plus x dx. So now we have an exponential function and we have polynomial, actually a monomial, x. We could split it into two integrals. We can make it the integral of e to the x dx plus the integral of x dx. But if you want to skip this step right here, you can just integrate each term separated by a plus or a minus, but right now we have a plus. So we're just going to integrate e to the x, which we know the integral of e to the x is e to the x. And then we're going to integrate x like we know how to do our power rule or integration, which is we add 1 to the exponent. So, or I can do it over here. We add 1 to the exponent, we get x squared. We divide the coefficient 1 by the new exponent 2, and we get 1/2 x squared. So our answer is e to the x plus 1/2 x squared plus c. So this problem is a combination of what we learned today, the integral of e to the x, and what we learned in previous lessons, how to integrate x. They're separate because they're separated by a plus sign. And then, of course, we put in our plus c. So our answer is e to the x plus 1/2 x squared plus c. How do I know there's no u du substitution here? Because all we have is this x in the e to the x. We don't have any complicated exponent. And this is simply an x. It's not a function within a function. All right, I hope you followed that. Let's look at one more here. So now we're back to integral of e to a power. This time the power is 3x plus 1. So that becomes our u. In these functions, most of the time, but not all the time, most of the time our u is the exponent. So u is 3x plus 1. And then we take the derivative of that and we get 3 dx. Now we come back and look at our original problem. There is no 3 here. The dx is here, that's fine, but there's no 3. So it's like those problems we've done before where we pick up a 3 that's not in the original problem. So we don't want the 3. So in this problem, we multiply on the outside of the integral by 1/3, just like we did in problems the other days. So 1/3, and then we're just integrating e to the u du. So the integral of e to the u is e to the u plus our c, and we bring down our 1/3. So our answer is 1/3 e to the u plus c, and then we put the x's back in. We get 1/3 e to the 3x plus 1 plus c. And now if you took the derivative of this, which I'm not going to do today, I might do some of them tomorrow. If you took the derivative of this answer, you would get back e to the 3x plus 1. All right, let's do, I think I have one more. Yeah, one more. Okay, so now this one is the integral of 5x e to the negative x squared. So again, we look for a function within a function. So our inside function is the exponent on the e, because negative x squared is inside the exponential function. It's serving as the exponent. So our u is negative x squared. Our du is negative 2x dx. We go back to the original problem. We have the x dx, there's the x dx, but in the du we picked up a negative 2 that we don't want. In the problem we have a 5 that we need, we can't get rid of. So if you remember what we did in those problems last week, we got rid of the negative 2 by multiplying the reciprocal of it in front of the integral, which is negative 1/2, and the 5, which we can't get rid of, we just move that in front of the integral sign. And so what we're going to get out here is negative 5/2. And then what our substitution is just, all we have left is just e to the u, and the du picks up the x dx. The 5 we moved out of the way, and the negative 2 we got rid of with a negative 1/2. So our integral looks like negative 5/2 times the integral of e to the u du. And we know that the integral of e to the u is e to the u plus c. We bring down our negative 5 halves, and then we will substitute back in our x's for our u. So we'll get negative 5 halves e to the negative x squared plus c. Okay, I think that's our lesson for today. I hope you followed that. And so I have some problems for you to do. And it's on section 5.3, page 336. It's numbers 1 through 11 odd. And you can email me with any questions on those problems or anything else in these problems at lgiswaldi@mbusd.org. Okay, I hope you followed this, and I hope you have a great day. Take care.